Hi everybody, welcome to class. We are going to do theoretical probability today. So you will need to have out your notes handout, your formative assessment on theoretical probability. Take notes on the back, and you also have a handout for two fair number cubes. It is this fluorescent orange in color. It has pictures of die on it and then the sums of the die. So make sure you have that handy. And theoretical probability is what should technically happen in an event. You still write it as a fraction, decimal, or percent, and you still denote it as a probability of your event. But in this case is what should happen, so you have an equal sign and then your outcome. And your outcome, again, can be a fraction, decimal, or a percent. So write down the notes, pause the video, what should happen in an event, and then probability of an event if you need this. This is a repeat. If you need it, write it down. Probabilities can be fractions, decimals, or percents. Theoretically, it's what should happen. Other words that you might want to know is equally likely. If you have a fair game or a fair event, then all probabilities are the same. So let's think of a spinner. If you divided it into 3 equal parts, each one would have a third of a chance of happening. So this would have a third, this would have a third, and this would have a third, or 33 1/3%. They're equally likely, or fair. Fair is the next word. Fair means if all outcomes are equally likely, then it's described as fair. If you flip a coin and you determine who goes first, you have heads and you also have tails. There are 2 outcomes. They're both 50-50, so it'd be described as fair. However, if you have a trick coin, if you have a 2 heads or 2 tails coin, this would not be fair because you'd have a 100% chance of one thing happening, getting a heads, and a 0% chance the other. That'd be unfair. Mutually exclusive events are disjoint events. Disjoint means are mutually exclusive. They're synonyms. It means the events can't happen at the same time. So for an example, if you roll a die, your probability of getting a number on a die are your sample space is 1, 2, 3, 4, 5, and 6. And if you spin a spinner, like the spinner above, you have 3 sections, you can get 1 out of the 3. If you roll a die, it has no effect on what you spin on the spinner. So that's called mutually exclusive or disjoint events. Mutually exclusive is the most common word here, but they're also known as disjoint events. One outcome cannot affect the other. They're mutually exclusive. All right, so let's just warm up. All possible outcomes are called the sample space. So you think about a number cube or a die. What are the possible outcomes? Your outcomes would be 1, 2, 3, 4, 5, or 6. So you have a fair number cube because each of the events are equally likely. There's a 1/6 chance of happening of rolling a 1, 2, 3, 4, 5, or 6. So like in the game of skunk that we played the other day on relative frequency, all of the outcomes were equally likely, so it was a fair game. So if you're playing cards and you have theoretical probability, notice there's a card behind here that's a 2. Sorry, this is a 2. It got cut off. Let me write that in a different color here. So that's a 2. What would be the chance of getting a red card? So to do that, you'd have to look at the cards and see how many are red. So 1, 2, 3. Sorry, that card behind was black in color. So the chance of getting a red would be 3 out of 7 because there are 3 reds out of 7 total cards. So now we're going to do some guided practice. Find the other side of your green sheet, and these will be on there so you can do your work right alongside, or if you'd rather do it on the back, that's fine. Have this handout ready. It'll really help you out. All right, so what's the theoretical probability using one die or one fair number cube to find the probability of rolling a 3? So to do this, you write the probability of 3 is, so it's an equal sign, then you have a fraction, and one die has a sample space of having 1, 2, 3, 4, 5, or 6. So since the sample space, there's 6 fair outcomes, what's the chance of rolling a 3? I have 1 out of 6. So that's my theoretical probability. Now in an actual experiment, relative frequency, I may not get a 3 1 out of 6 times. Theoretically though, I should. Let's look at another example. The probability of getting a 1 or a 4. This is number 3 on your formative assessment. So the chance of getting a 1 or a 4, you'd have to take the probabilities of getting a 1 or a 4. So it's the same sample space. And I would write this on the top of your paper, 1, 2, 3, 4, 5, 6 for the sections 1 through 8 in your formative, because this is a sample space that you're dealing with. So our probability is trying to be a 1 or a 4. So how many 1s or 4s are there in the sample space? I have 2 out of 1, 2, 3, 4, 5, 6. 2 out of 6. This is not done yet. I have to reduce it. So the probability of getting a 1 or a 4 isn't 2/6, but it's the reduced fraction of 1/3. So that's your final answer. Again, it can be fraction, decimals, or percents. In this situation, it is most likely easier to do fractions for you. Okay, let's do again. Probability of it not being 5. This is number 4. So if you're using one die, again, your sample space is 1, 2, 3, 4, 5, and 6. All possible outcomes. This is called your sample space. The list of all possible outcomes is your sample space. Hint, hint, test question. All right, so the probability of it not being a 5, that means it could be a 1, could be a 2, could be a 3, could be a 4. It can't be a 5, but it could be a 6. So how many outcomes do you have that are not 5? I have 5 out of a total of 6. That's reduced, so that's my answer. Now you're going to want to look at the other side, the sum of the number cubes. These are 2 die. So this is for numbers 9 through 17, or 9 through 19, excuse me. You're going to want to use this information. Now this is all it is a sum. I took 1 and 1 and added together at 2. So that's the sum of the dies. The reason being is because I want to know the probability of the total being 13. Well, if the probability has a total of 13, I'm going to look at the sum cube. It's going to help me a lot more than thinking of all the possible outcomes. This is a sample space. All possible outcomes, but the total being 13. What's the chance the total is 13? Well, how many add up to 13? 0. 0 out of how many? 1, 2, 3, 4, 5, 6. 6 by 6 is 36. 36 possible outcomes when you roll 2 die. So my probability of a 13 is 0 out of 36, also equal to 0. So on your homework, this is number 14 on your formative. So the probability of being equal to 13, the sum, is 0 out of 36, which is 0. Final answer. Again, use this one for having a total shown 6, 7, or 8. This is number 19 on your formative. So if you look over here, what's the chance of having a 6? So you count these up. I have 1, 2, 3, 4, 5 of them. Chance of having 7. 1, 2, 3, 4, 5, 6 possible outcomes. Chance of having a sum of 8 are 5 possible outcomes. So I add 5 and 6 and 5 together to get a total of 16. So my chance of having a probability of a total of 6, 7, or 8 is 16 out of 36. Then I want to make sure I simplify my fraction. So you can either use the ABC button, or you could divide by 4 over 4, your greatest common factor. So if you divide by 4 over 4, you'll also get your reduced answer of 4/9. That's your final answer. We're going to do another type of problem, theoretical probability. If a bag has 2 dimes, 3 nickels, how many pennies should be added so the probability of drawing a nickel is 1/7? Whoa, did I just blow your mind? Because this is a tough question. We're going to do 2 different questions like this. There'll be one on your homework. There'll also be one on your summative. So first you need to think about how you set this up. How many nickels do you have already? We have 3. I want the probability of a nickel to be 1/7. So I'm going to set it equal to 1/7. So to figure out your probability, we need to set up a proportion. Whenever I see the word proportion, I think fraction bar equals fraction bar. So fraction bar equals fraction bar. And how did I get this? Well, I want it to be equal to 1/7, so I put 1/7 on the right side. I have 3 nickels, so I put the 3 up top. I have 5 coins already because I have 2 plus 3 is 5, and then I'm going to add some more. I don't know how many, so I put a variable in for x to represent the number of pennies that I'm adding. Notice that I'm not adding nickels, I'm adding another coin. It's not going to affect my numerator, just my denominator. It's going to affect my total. So now I have a proportion. To solve a proportion, I use cross products. It's like a squiggle problem. So I'm going to do it on this page here. I do 5x plus 1 times 1. 5 plus x multiplied by 1. Well, you could use the distributive property if you remember how to do that. 1 times 5 is 5. 1 times x is x. Or you know that 1 times anything is itself equal to the other side, 7 times 3. And 7 times 3 is equal to 21. So now you have what we like to call a squiggle problem. We just have to balance this equation to isolate our variable. So I subtract 5 from both sides, and I get 16. So I would need to add 16 pennies for my probability of drawing a nickel to be 1/7. So 16 would be my answer. Now we're going to do one off of your homework or your formative assessment. Number 18. A bag contains 9 pennies, 8 nickels, and 5 dimes. How many quarters, again we're adding something that's not going to affect your numerator, should be added to the bag to get a probability of drawing a dime to be 1/6? We want it to be 1/6, and I know I'm going to have a proportion, so you set up fraction bar equals fraction bar. Now, how many total coins do I have? I have 9 plus 8 plus 5. When I add 9, 8, and 5, I get a total of 22. Your total is always going to go in your denominator, but then I'm going to add some more coins. I don't know how many, so for now I'm going to use a variable to represent that number. I'm going to say x. Let x be the number of quarters that I'm adding to the bag. How many dimes do I have right now? And it's very important to write what you're looking for so that you know what to put in your numerator. I'm looking for dimes, so I put a 5 up top in the numerator. Now I need to solve using cross products. So I'm going to take the quantity of 22 plus x and multiply it by 1. 1 times anything is itself. So I have 22 plus x on one side of my equation and 6 times 5 on the other. 6 times 5 gets us a product of 30. So I write 30. I multiplied 6 by 5 to get 30. Now to isolate my variable, I need to balance this equation. I subtract 22 on both sides of my equation. If you want to squiggle it, you can. I bring down my variable, and now my variable is isolated. And when you subtract, you get a difference of 8. So I would need to add 8 quarters to my bag to have a theoretical probability of drawing a dime to be 1/6. Work on, my friends. Make sure you do your best. Theoretical probability for all y'all. We're going to have it at 100%, equal to 1. Let's do this. Ask for help. Again, thank you so much for being here. I appreciate all of you. And thanks for watching.